Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 3 from the May-June 2021 paper 4 variant 2 IGCSE Cambridge paper from the 0580 syllabus. Says simplify, giving your answer as a single power of 7. So in all these cases we have to give the answer in terms of powers of 7. So for the first example here, we're multiplying two numbers. They both have the same base of 7 and we're multiplying them, so we have to add the power. So it's 7 to the power of 5 plus 6 gives you 7 to the power of 11. You add the powers. Why? Because this is like 7 times 7 times 7, 7 5 times, and this is 7 times 7 times 7 times 7, altogether 6 times. So altogether you're going to have, if you write it all out, you're going to have 11 sevens multiplied by each other, which is 7 to the power of 11. And here we got 7 to the power of 15 divided by 7 to the power of 5. In this case, when we are dividing numbers in index form with the same base, we have to subtract the power. So it's 7 to the power of 15 minus 5, which is 7 to the power of 10. And we can understand this also if I were to write 7 times itself 15 times divided by 7 to the power of 7 times itself 5 times. 5 of those 7s will cancel out, leaving you with 10 sevens on the top. So you got 7 times itself 10 times, which is 7 to the power of 10. 42 plus 7. Now here what I can do is I can rewrite 42 as 6 times 7. Okay. Simplify, giving you answers a single power of 10, and that's plus 7. All right, 6 times 7 plus 7, and that would therefore be 7 times 6 plus 1, which is the same as 7 times 7, which is 49, which is 7 squared. Alternatively, I went about that in a bit of a long way. Alternatively, that's fine what I did, but this is much easier. Just add them together. That gives you 49, and we know that 49 is 7 squared. Okay, so that's a bit easier. So you just add them together, you get 49, which is 7 squared, which is a single power of 7. All right, now part B says simplify 5 to the power of 5x squared plus 2xy to the power of 4, all to the power of 3. All right, so what I can do is I can multiply what's inside the bracket first. So I'll have 5 times 2, which is 10. I'll have x squared times x, which is x to the power of 3. Remember, there's like a 1 here, so we add those powers. And we've got y to the power of 4. And all this has to be raised to the power of 3. So we're going to use the rule. Well, for the number, I'll just say that take this as 10 cubed, which will be 1,000. 1,000. 10 cubed is 10 times 10 times 10, which is 1,000. For the indices, I'll use the rule that if you have something raised to a power to another power, you have to multiply those powers. Okay, so x cubed cubed. X cubed to the power of 3 means x cubed times x cubed times x cubed, which is going to be x to the power of 9, because you're going to have to multiply those powers. You're going to have x cubed times x cubed times x cubed. So you add these 3 powers when you're multiplying them. That gives you 3 plus 3 plus 3, which is 9, which is the same as just multiplying the powers in the first place. You have y to the power of 4 raised to the power of 3. 4 times 3 is 12. That gives you 1,000 x to the power of 9 and y to the power of 12. You multiply the powers when you raise them to another power. Okay, so there's the answer to part B of question number 3. Now for part C. Now this is the question where people were having or asking me about. So it says P is equal to 2 to the power of 5 times 3 cubed times 7, and Q is equal to 540. Find the highest common factor of P and Q. So what I'm going to do first is I'm going to rewrite Q in this form when I've written it out as a product of its prime factors. So you can do this in various ways. I'll use the ladder technique here. I'll take 540 and I'll divide it by 2 first. 2 goes into 5 2 times, remainder 1. 2 goes into 14 7 times. You've got the 0 at the end. 2 also goes into this number, so I can divide it by 2. 2 goes into 2 1 time. 2 goes into 7 3 times, remainder 1. 2 goes into 10 5 times. Now 2 won't go into this number because it ends with an odd number, it's not even. If I add the digits, 4 plus 5 is 9. That means 3 goes into this number because 3 is, 9 is divisible by 3. The sum of the digits, if it's divisible by 3, that means the number itself is divisible by 3. So 3 will go into this number. 3 goes into 13 4 times, remainder 1. 3 goes into 15 5 times. Again, if I add these together, I get a number divisible by 3. So 3 goes into this number. 3 goes into 45. 3 goes into 4 1 time, and into 15 5 times. 15. Again, 3 goes into 15. 5 times, 3 doesn't go into 5, the next prime number is 5, 5 goes into 5 one time, and we finished. So I can say 540 is equal to 2 squared times 3 cubed times 5. So what I'm going to do, I'm going to write P and Q on top of each other, and I'll write the same powers, the same bases on top. So 2 to the power 5 times 3 to the power 3. I'll leave a space for the 5, we've got one there. I'll put times 7 here, and from Q I'll put 2 to the power 3. Sorry, it's 2 to the power 2. It's 2 to the power 2. 2 to the power of 2. Be careful about making silly mistakes like that. That's 2 to the power of 2 times 3 to the power of 3 times 5. Now what I'm going to do to find the highest common factor, there's different methods I'm going to use, or we can use, but I like to use a method where I look at the common numbers, which are 2 and 3. 5 and 7 has nothing in common, okay, in both numbers, but the ones that are common to each other, I take for the highest common factor, I take the lowest form of each of these. So 2 to the power of 5 and 2 to the power of 2, well, 2 to the power of 2 is the lowest form. 3 to the power of 3 and 3 to the power of 3, well, it's just 3 to the power of 3. Okay, it's the same in both, so I have to write that down. For here, this doesn't have a 5, and this doesn't have a 7. In fact, this actually does have a 5, which is actually 5 to the power of 0, which is equal to 1. And that's the lowest form. That's why if you write 1 down, 5 to the power of 0 down, its value is 1, it won't change this. Same here, you can think of this as 7 to the power of 0, which is the lower form of this, because this is 7 to the power of 1, this is 5 to the power of 1. And again, 7 to the power of 0, its value is 1, so that won't affect this number. So the highest common factor, so that's another way of thinking. We're taking the lowest form of each of those to find the highest common factor. So this is going to give us 4 times 27, which is 108. That's the highest common factor. Then it asks us for the lowest common multiple. For the lowest common multiple, we use a very similar technique, except this time we take the highest form of everything. So in this case, it's 2 to the power of 5. And in this case, it's 3 to the power of 3. Now, here, the highest form of these two, as I mentioned before, this is like 5 to the power of 0, and this is like 7 to the power of 0, it would be 5. And here it would be 7. So when you have the lowest common multiple, you take the highest form of everything, including the ones that aren't common. You can kind of think of them being common as to the power of 0 if you want to make it a bit, easier. But most people just think about this as you write everything you see down, whether it's in both lists or not, but in its highest form. Okay, so this will give us the answer for the LCM, which will be, let's work that out. We're going to have 2 to the power of 5 multiplied by 3 to the power of 3 multiplied by 5 multiplied by 7. That gives us 30,240. 30,240. That will give us the lowest common multiple. That's the highest common factor. That's the lowest common multiple. Then for part 2, it says P times R is a cube number where R is an integer. So R is not a number in these. It's just we have to deal with P. So we know that P is equal to 2 to the power of 5 times 3 cubed times 7 times 3 cubed times 7. And R is an integer. So we know that P times R is a cube number. So we've got to find the smallest possible value of R. So when you take this number, 2 to the power of 5 times 3 to the power of 3 times 7, and you multiply it by R, you will end up with a number which is a cube number. Now, the cube number that we're going to get, all right, a cube number is a number, okay, when you break it down to its prime factors, the powers of the prime factors must be multiples of 3. They must be multiples of 3. So that means this has to be 2 to the power of 6. This is 3 to the power of 3. That's fine. That doesn't have to change. That is a multiple of 3. But 7 has to become 7 to the power of 3. Okay, so if we think about it, the R must be equal to what makes 2 to the power of 5 become 2 to the power of 6, which is 2. 3 doesn't have to be changed, but 7 to the power of 1 becomes 7 to the power of 3, so that's going to be 7 squared. So R must be 2 times 49. 2 times 49, which is 98. So R must be 98, because that's what the value of R has to be. That will make these become cubed or multiples of 3. The 2 to the power of 5 becomes 2 to the power of 6, 7 to the power of 1 becomes 7 to the power of 2. How? You have to multiply by this number here. Okay, you could, if you want, use an algebraic method here, say that therefore r is equal to 2 to the power of 6 times 3 to the power of 3 times 7 to the power of 3 divided by this 2 to the power of 5 times 3 to the power of 3 times 7 to the power of 1. And you see the 3's cancel, you're left with 2 times 7 squared, which is 2 times 49, which is 98. Okay, so there's part 3 of this question. And that concludes this question. Question number 3. Is it 3? Yeah, from this paper, May, June 2021. The question that the student who asked this question for me was part 3 here, but I went through the whole question anyway. So other questions you might want to find from this particular paper will be found in the playlist that should appear in this area here. Other questions about prime factorization and basic arithmetic can be found in this chapter, in this playlist over here, and you can subscribe to my channel by clicking on this link. Also in the description you might find some links to my subject and paper indices for AS and A2 and IG material, so you might find that useful. Thank you for watching and see you soon.